Hey, alright, guys, now let's get started today, and I'll be answering all the questions that were being asked in the interview last time, which I was supposedly not able to answer most of them. So, these are just minor questions, but these actually require a perfect answer to be studied before answering. So, let's get started one by one. And the first question is, what is latency and scalability, and how do they go hand in hand? ओके बहुत ही ज़्यादा सिंपल क्वेश्चन है, तो अब इसका मैं आंसर आपको बताता हूँ. ठीक है, लेटेंसी एंड स्केलेबिलिटी, ठीक है, दो सॉफ्टवेयर इंजीनियरिंग सिस्टम्स के लाइक दो कंसेप्ट्स हैं. ठीक है, लेटेंसी इज़ द टाइम इट टेक्स फॉर अ सिस्टम टू रिस्पॉन्ड टू अ रिक्वेस्ट. ठीक है, मतलब क्या है कि रिक्वेस्ट जाता है सर्वर के पास. ठीक है, सर्वर के पास जाके फिर वो पता नहीं, मतलब इट गोज टू द डेटाबेस क्वेरी और व्हाट, तो मतलब जो भी उसका प्रोसेसिंग करना है, और फिर जब रिटर्न आता है तो दैट इज़ कॉल्ड दी टोटल लेटेंसी. You click the login button, that request travels to server processes it, the request comes back, and that is the total time is called the latency, which is 100 ms. Okay, and the faster responses is better user experience. ऑलराइट, तो अब स्केलेबिलिटी क्या है? तो स्केलेबिलिटी इज द एबिलिटी टू इंक्रीजिंग लोड विदाउट अफेक्टिंग सिग्निफिकेंट परफॉर्मेंस डिग्रेडेशन. ठीक है, तो आज 100 यूज़र से सिस्टम इज़ वर्किंग फाइन, कल के दिन समझो 10,000 यूज़र्स आते तो सेम परफॉर्मेंस रहना चाहिए, मतलब सिस्टम से स्टिल वर्क फाइन. दैट इज़ अ स्केलेबल सिस्टम. ओके, एंड देर आर टू कॉमन टाइप्स. ये आंसर करना था, मतलब थोड़ा, हाँ भाई, इनको पता है वर्टिकल स्केलिंग क्या है, हॉरिजॉन्टल स्केलिंग क्या है. ठीक है, तो वर्टिकल मतलब में क्या होता है, सीपीयू रैम वगैरह फास्टर डिस्क एक ही मशीन में ऐड करते हैं. हॉरिजॉन्टल में क्या होता है, मल्टीपल सर्वर्स, सेम सर्वर्स हम लोग ला के उसमें रखते थे, और दे ऑल द सर्वर्स हैंडल द रिक्वेस्ट, however the load is on each server. Okay, we probably use load balancers or what to assign the each server into however load it can accept to run efficiently. Okay, how do they go hand in hand? अब ये बहुत ही ज़्यादा इंपॉर्टेंट सवाल है. तो लेटेंसी एंड स्केलेबिलिटी आर क्लोजली रिलेटेड बिकॉज मोर यूजर्स यूजुअली इंक्रीज लेटेंसी. ये सेंटेंस अगर मैं बोल देता था, दैट्स इट ब्रो, किलिंग इट. ओके, इमेजिन अ सिचुएशन. हाँ, तो ये सिचुएशन है, ब्ला ब्ला ब्ला. ओके, एंड improving the scalability means often helps maintain low latency under the hood, but sometimes the techniques can be used to add latency. Okay, sometimes the techniques can add latency. Okay, so load balancer, better scalability, impact latency, a small extra hop, database sharding better, sometimes extra coordination. ठीक है, तो ये सारे systems जो है, they often had a little bit of latency anyways. And there was one more thing which was very important, so we add a bit of caching, you see. So I don't know where I've kept it, but yeah, that's there. Okay, real world example, thousands of server worldwide, so you can read this. Okay, latency response for one request, scalability, ability to keep latency acceptable for load as load increases. Okay, interview friendly definition, latency is the time required to complete a request, scalability is the ability to of a system to handle increasing load efficiently. Handle करता है scalability. They are related because a scalable system is designed to prevent latency from growing significantly as the number of users, requests, or data volume increases. Next question, how do you keep your latency low while the system is scaling under the heavy load? Keeping the latency low while scaling is one of the key main goals of the distributed systems. Okay, the design is to prevent requests from waiting in queues and hitting overloading components. So basically, first thing what we do is scale horizontally before the components saturate. Okay, increasing one server handling everything instead of one server handling anything. As the request grows, तो हम लोग और servers उसमें add करते हैं. Why it helps? CPU and memory usage stay low per server. ठीक है, requests spend less time waiting and responses remain under consistent. ठीक है, time remain under consistent. तो use caching aggressively. ये क्या करता है? तो कैशिंग अवॉइड्स एक्सपेंसिव वर्क. ठीक है, कैशिंग में क्या होता है, रिक्वेस्ट आता है एप्लीकेशन को नॉर्मल में. ठीक है, एप्लीकेशन से डेटाबेस जाता है, बट कैशिंग में क्या होता है, रिक्वेस्ट, कैश एंड डेटाबेस ओनली ऑन कैश मिस, ठीक है, ओनली ऑन कैश मिस वो डेटाबेस से जाता है, इफ नॉट इट डायरेक्टली रिटर्न्स फ्रॉम द कैश। वी कैन यूज़ रेडिस और मेम कैश, जिस रेडिस का वीडियो ऑलरेडी बना हुआ है चैनल पे। एग्जाम्पल्स, प्रोडक्ट कैटलॉग, यूज़र प्रोफाइल्स, सर्च रिजल्ट्स, सेशन डेटा। Caching often reduces latency from hundreds of milliseconds to a few milliseconds. Okay, reduce database bottlenecks. Okay, whatever that is. Okay, synchronous dependencies. Yeah, that's it about the question. All right, so it's gonna be the next question now, and the question is interviewer is asking me on the set. Okay, तो मैंने बताया था कि resume में कि I've reduced like 45% latency of our services. So the question obviously was like, what did you do to reduce this latency in your server, which I was using Spring Boot on. Okay, तो सबसे पहले तो ये 4 क्वेश्चंस भी उन्होंने पूछे थे, ठीक है। सबसे पहला ये क्वेश्चन पूछा था उन्होंने, हाउ डिड यू मेजर योर लेटेंसी, ठीक है, एंड देन व्हाट स्पेसिफिक चेंजेस यू मेड इन द स्प्रिंग बूट एंड व्हाई दोस चेंजेस वर्कड। बॉटलनेक वाला तो शायद नहीं पूछा था, ठीक है, आई डोंट रिमेंबर एग्जैक्टली। एनीवे, सो ओके, बेसिकली वी नोटिस द API रिस्पॉन्स टाइम वाज अराउंड 800 ms एट P95। अब ये P95 क्या है ये भी मैं बताता हूँ आपको। ओके, तो what is P95? It's basically like the 95 percentile latency is a metric that tells you 95% of requests completed within this time response time, take only 5% request took longer। लाइक फॉर एग्जाम्पल अभी समझो 95% जो है वो इस रेंज में आता है, ठीक है, इस रेंज में आता है करीब करीब, और जो 5% में आता है वो ये दोनों आते हैं, ठीक है। तो अगर हम लोग इन सबका एवरेज लेंगे तो वो एवरेज क्या होने वाला है 364 ms, विच इज़ नॉट एक्जैक्टली ट्रू, राइट। मतलब अपने ऑलमोस्ट सारे रिक्वेस्ट इसी टाइम फ्रेम में आता है, एक खाद दूसरा बस ज़्यादा हो रहा है। ओके, तो दैट इज़ द रीज़न वी टेक 95, P95। ओके, तो इतना याद रखो ये चीज़ कि देर आर अदर मेट्रिक्स एज वेल बट वी यूजुअली यूज़ P95 आर फास्टर। Okay, and yeah, so let's move forward with our thing. Okay, so yeah, reduced database calls, this is most common real world asked question। Okay, real world asked answer। तो बिफोर इट वॉज वी आर यूजिंग दीज थिंग्स, ठीक है, हम लोग पहले यूज़र रिपोजिटरी में जाके यूज़र की आईडी फाइंड कर रहे हैं, फिर ऑर्डर्स में जाके उस पर्टिकुलर यूज़र की आईडी फाइंड कर रहे हैं, उसके बाद हम लोग एड्रेसेस में जाके उस पर्टिकुलर यूज़र के एड्रेसेस फाइंड कर रहे हैं अपन। तो दिस इज टेकिंग 3 databases कॉल, or in case of what we if we use the query, right, so directly in one query we are getting everything, we don't have to go to and fro to get the answers। Okay, benefits, fewer network trips to database, less query execution time, lower response latency। Okay, um, we identified n plus one query issues in Hibernate and replaced them with fetch joins and optimized queries, reducing database or round trip significantly। अब ये Hibernate के क्या इशू है वो भी अपन देख लेते हैं। Okay, so basically what is this Hibernate? Okay, Hibernate is an ORM, relational mapping। Okay, Java objects into database rows and vice versa। Instead of writing this you write this। Oh, Hibernate generates SQL for you, get it? This is Hibernate। अब ये confusion भी दूर हो गया। ऑल राइट, ओके, तो हम लोग n+1 वाले को हम लोग डेटाबेस क्वेरी में चेंज कर रहे हैं। ओके, ओके, so what we did is we identify n+1 query issues, n+1 in this case is like multiple database queries in Hibernate, and we have used SQL for this। Added caching, okay, for frequently accessed data before it was calling it directly, and we use a cacheable annotation which basically caches this thing, because products har bar lagega and we can't just go ahead and pull the products from the product table each time। We can use Redis for this, we can use cache for this, and we can use cache annotation for this। Okay, so that's that। Optimized for slow queries, अब क्या है Okay, first we use redis caching for frequently accessed data etc. तो ऑप्टिमाइज स्लो क्वेरीज, तो सिलेक्ट हम लोग ऐसे करते थे। अब क्या करना अपने को, बिफोर डूइंग दिस वे अभी भी अपने को सिलेक्ट ही करना है, बट वी यूज़ क्रिएट इंडेक्स इन द डेटाबेस कॉल इटसेल्फ। ठीक है, तो ये क्या करता है, ये क्रिएट इंडेक्स क्या करता है, तो इसका भी जवाब है अपने पास। ओके, आई डेंट गेट व्हाट दिस क्रिएट इंडेक्स डज। सो बेसिकली without an index, the database has no shortcut. It scans each row one by one. This is called full table scan. Time complexity is roughly O of n. If the table has millions of rows, it can be slow. With an index, you can create this, create index wala thing, and the database builds a special data structure, typically a B tree. अब बी ट्री क्या है वो अलग वीडियो में मैं बता दूंगा। दैट लुक्स कंसेप्चुअली लाइक दिस। ओके, अब इसका टाइम कॉम्प्लेक्सिटी कितना था, अगर आप भी अपन सेलेक्ट क्वेरी करते हैं ना, तो फिर अपना टाइम कॉम्प्लेक्सिटी आता है ओ ऑफ एन, ओ ऑफ सॉरी लॉग एन। पहले इट वाज ओ ऑफ एन, नाउ इट इज़ ओ ऑफ लॉग एन, विच इज़ मच मच फास्टर फॉर लार्ज टेबल्स। ओके, यहाँ पे आप देख सकते हो हाउ मच टाइम इट रिक्वायर्स विद इंडेक्स एंड विदाउट इंडेक्स। ओके, now let's move forward. Okay, we have used indexing. अब इसका आंसर क्या दे सकते हैं, we have analyzed slow queries, added missing indexes and optimized execution plan with reduced query latency. अब async processing, okay, we have removed non-critical work out of the request path, like for example send email and generate report जो होता है, तो हम लोग उसको हटा के we used other asynchronous task for this, like background worker अपने को email तो send कर सकता है, तो we can use this thing obviously. Faster user responses because we have reduced unwanted tasks. Okay, and reduced the payload size. Next is the reducing the payload size. So jo elements are not required, right, we should not send them, and we have created specific DTOs where only we return the DTO data. Okay, less serialization, less network transfer. Okay, and which actually helps us. We introduce DTO projections and reduce the response payload size, improving serialization and network performance. Okay, and then this point is connection pooling, pool tuning. Spring Boot often uses Hikari CP. Okay, and this is the thing. Okay, pool size. If too few connections exist, request wait latency increases. Interview. We tuned Hikari CP connection pool settings based on traffic patterns to reduce the connection acquisition wait times. Now I need to study about this. I am not sure what this exactly means, but yeah, let's proceed. 7 parallel calls. Before it was like service sequential, but after what we have done is completable future dot all off. Okay, parallel execution होता है इससे total latency becomes close to the longest call rather than the sum. समझो रिक्वेस्ट सी को सबसे ज़्यादा टाइम लग रहा था, रिक्वेस्ट ए भी बहुत फास्ट हो रहे थे। ठीक है, लेट्स से 1 सेकेंड 2 सेकेंड एंड 5 सेकेंड्स, तो टोटल 8 सेकेंड्स लग रहा था। बट इन पैरेलल केस क्या होता है, 1 सेकेंड 2 सेकेंड तो पैरेलल ही होते रहते हैं, और ये 5 सेकेंड जो है सबसे ज़्यादा टाइम किसको लगा, 5 सेकेंड्स को। मतलब इन सब को रन होने में टोटल टाइम लगेगा 5 सेकेंड्स, बिकॉज दीज आर इन पैरेलल नाउ। ओके, so yeah, this is the strong answer. You can read about this answer if you actually worked on a Spring Boot backend. A believable answer is we have noticed high API latency through monitoring. Profiling showed most of the time spent in database access. We fixed n+1 query issues with Hibernate, optimized SQL queries with proper indexing, introduced Redis cache for frequently accessed data, moved on non-critical operations such as notifications to asynchronous processing. We measured API P95 latency before and after deployment, and we saw approximately a 45% reduction in the latency. The interviewer will usually ask the following: how did you measure 45% latency? Yeah, we will study that thing, but first I need to make sure that and move non-critical to asynchronous processing. How did you do this? Or if possible, if we could, yeah, how did you do this, and how did you measure? And next question to answer would be, yeah, this. These are exactly the kinds of follow-up questions the interviewer asks. Okay, how did you move notification to asynchronous processing problem? Originally it was calling from this, right? Create order, send email. Okay, user waits for the email operation to finish. That's true. Spring asynchronous. All right, configurable asynchronous, enable async. All right, so email service basically has async and send confirmation email. Okay, and controller. So controller what it does is send confirmation email. तो ये completely एक separate service class रहने वाला है, and we just add our task to this particular list basically. तो we do this and it automatically जैसे उसको time मिलता है it sends the email without blocking our current code. Okay, solution to more enterprise, publish an event. That is what I was saying, you know. So create an order, and yeah, the listener listens to it whenever it has time. Very common in Spring Boot. Okay, publishing an event. All right, next question: how do you measure the 45% latency? This is more important question. Okay, interviewers want to know how did you actually measure, or how are you inventing numbers? Good answer. Say before optimization P95 latency was 800, after optimization it was this. So calculation is around 45%. If you used actuator plus micrometer, okay, matrix exposed to matrix, sent to Prometheus and Grafana, you monitor. Okay, look at P50, P95, P99. Yeah, this is a good answer, so I'll tell you. So basically I would rather say that because I am not sure about the Grafana and the actual things like micrometer and stuff, so what I would rather say is I have used P95, P99 and P90, all of these results, and took the average of all those, and basically before doing our optimizations it was at around 800 ms, and after optimization it was around 440 ms, or whatever I would say at the time of interview. And if we take the percentage calculation, it was around 45%. Okay, so that is what I would say. Okay, many teams used load testing using Apache JMeter. Okay, so I would need to know how the JMeter works before saying this answer. Okay, so yeah, that is about that question. Let's proceed on to the next question. All right, so as I said, the next question is if I had a simple Spring Boot application, how would I reduce its latency? So how would I reduce its latency, right? So first is going to be to measure exactly. Okay, uh, request flow, database query times, external API calls, CPU usage, and application logs. This is important because you shouldn't optimize blindly. All right. Step 2, check the database. In most Spring Boot applications, this database is the biggest latency source. Okay, so add indexes on frequent queried columns, like I said earlier. Fix n+1 query issues, like I said earlier. Optimize slow SQL queries, and then fetch only required columns using DTO. Use pagination instead of loading huge data sets. Okay, so instead of loading the huge data entire entity graphs, we could use this. Okay, then introduce caching, as I already said. Okay, in memory or redis, both can work. इससे क्या होता है, fewer database calls आते हैं, faster responses आते हैं. Remove work from the request path. तो मतलब email जो बीच में आता था उसको निकाल दो और sync tasks में उसको डाल दो. And reduce external service latency, so call the services parallelly, and instead of calling them one by one, if we have user service, payment service, notification service, etc. So tune Spring Boot as well. So database, avoid request waiting for the database connection. So maybe इससे क्या होता है, if we increase the pool size, multiple requests can access the database at the same time instead of waiting until the size becomes to 20 again. Okay, so yeah, and and then reduce data serialization overhead. Instead of returning multiple data, okay, so we return only what is needed, the smaller payload, faster serialization, and less network traffic. Okay, so these are things you can read this answer as well, and yeah, you're good to go. And then yeah, next question. All right. So as I said, how the next question is how would you reduce, how would you use parallelism in Spring? Okay. तो कैसे यूज़ कर सकते हैं? How would you use parallelism in Spring Boot to reduce the latency? Correct. तो अभी sequential execution which is slow. Okay. तो ये क्या करता है? एक रन करता है. ठीक है. Assuming 200, 300 and 400 seconds लगते हैं each method को complete होने. Total latency is 900 ms. तो parallel execution में क्या करते हैं अपन? सबसे पहले class में हम लोग क्या करते हैं? Enable async यूज़ करते हैं. And then when we go to the methods, we use async @async for the methods as well. Okay. And then how we do execute it together, तो basically हम लोग यूज़ करते हैं completable future, और इसमें हम लोग उसको एग्जीक्यूट करते हैं. तो तीनों को हमने इसी में डाल दिया है. ओके. कंप्लीटेबल फ्यूचर में. एंड देन फाइनली कंप्लीटेबल फ्यूचर डॉट ऑल ऑफ यूज़ करके इसके अंदर सारे हम लोग जो वेरिएबल्स है तो हम लोग उसको यूज़ करते हैं. ठीक है. तो या सो रिट्रीवेबल रिजल्ट्स. अब इसका जो एम एस है इट्स अराउंड 400 ms बिकॉज द मैक्सिमम टाइम रिक्वायर्ड फॉर द ऑल द मेथड्स टू बी completed is 400 ms, so therefore we written 400 ms. Okay, so we have saved a lot of time. So but in the real world examples, right, parallelism is useful when multiple microservices use parallelism at the same time instead of using user payment and loyalty. So call them together. Multiple database queries, sometimes different repositories fetch unrelated data. Okay, this can be parallelized if they are true. Okay, if they are truly independent and your DB can handle the extra concurrent load. Okay, so that's that. And let's see what we call these guys. Objects. I'm so sorry. Yeah. Alright, so the next question is, forget Spring Boot, using plain Java, how did you reduce the latency, right? For the answer for this is basically like the core concepts. Okay, so reduce unnecessary work. For example, अगर for loop आ रहा है and if calculate expensive report is called repeatedly for the same input cache, the result to avoid the duplicate calculations. ठीक है, तो cache करना है अपने को for duplicate calculations. यूज बेटर डेटा स्ट्रक्चर्स. लाइक फॉर एग्जांपल अगर अपने पास एक लिस्ट है एंड वी आर यूजिंग कंटेन्स लिस्ट में, सो दैट्स अ बैड थिंग. ओके, इट टेक्स अराउंड कंटेन्स टेक्स ओ ऑफ एन. इंस्टेड व्हाट वी यूज इज अ सेट. ओके, एंड दिस हैज़ ओ ऑफ वन लुकअप टाइम. सेट में कभी भी हम लोग क्वेरी करते तो ओ ऑफ वन ही रहता है. ठीक है, तो दिस रिड्यूसेस लेटेंसी सिग्निफिकेंटली. तीसरा क्या है, यूज़ पैरेललिज्म फॉर इंडिपेंडेंट टास्क्स. ओके, तो तीनों अलग अलग हैं. तो व्हाट वी डू इज़ वी यूज़ फ्यूचर्स इन दिस केस. तो आई नीड टू स्टडी अबाउट द syntax we use for this. Okay, but this does reduce the latency time. Then reduce the IO operations. Okay, so write to file for if we are using in the for loop, instead of that we use the buffered writer. Okay, then we use caching as I said. So for the expensive computation or calculations we use this. Avoid excessive object creation. So like if you can see here, okay, and then use effective algorithms and hash sets wherever possible. And profile before optimization, look for what the bottlenecks are. If the bottleneck is CPU bottlenecks, memory bottlenecks, contention, IO weights, or what exactly it is, and then process on it. So this is very important step. Okay, because we need to analyze what we are actually doing, right? So then we can do that. So I guess that actually completes all our questions. We have already answered this question, and yeah. All right, so one last question actually. So the question was like, you said the automation manual process and reduced headcount workload by 40%. What exactly did you do? Please explain in technical detail. Okay, so this question is dangerous. If the 40% reduction isn't backed by something concrete, interviewers will keep drilling down until they understand exactly what was automated. So that is exactly what happened again. Okay, and use the structure. What was manual? What was the pain point? What did you build? What did you work technically? How did you work technically, and how did you measure the impact? All right, example answer 1. If you automated a report process, the team was manual generation. The team was manually generating operational reports every day. An analyst would extract the data from multiple database tables, clean it in Excel, apply business rules, and then sell the report to stakeholders. This process took roughly 3 to 4 hours per day. I built a Java-based automation service that schedules a report generation. The service queried the required data directly from the database, performed the transformation programmatically, used business rule logic, generated CSV Excel files, and automatically distributed them via email. Technically, I implemented the scheduled jobs that executed the predefined intervals, used JDBC JPA to fetch data, applied transformation logic within the application layer, generated reports, and logged execution status monitoring and error handling. After deployment, the manual effort dropped to approximately 20 hours per week to around 12 hours per week across the team, which was around 40% reduction in the workload. Example answer: if you automated ticket processing, support engineers were manually reviewing. हाँ, अगर ये दूसरा एग्जाम्पल आंसर है तो टिकट ऑटोमेशन के लिए, so support engineers were manually reviewing the incoming requests, categorized them, assigned priorities, and routing routing them to appropriate team. I developed a workflow automation service that validates incoming requests, applied predefined routing rules, assigned categories automatically, and created tickets in the appropriate queue. The system used rule-based processing where request attributes were matched against configurable criteria. Previously, every request required human intervention. After automation, only the exception cases required review. As a result, the team handled significantly more requests with the same staffing levels, and the manual processing effort was reduced by around 40%. Okay. So yeah, that's it for this video. Yeah, it's become a little longer than the usual videos, but yeah, let's stop this video now. Thanks for watching.